Okay, so this is number 4 from last night's homework on simplifying complex fractions. And we need to, like we did in class yesterday, multiply top and bottom of this fraction by a common denominator to get rid of all the fractions within the problem. Now, one thing that you could do with this problem, it's kind of outside of what we normally do, so I'm not going to suggest that you do this. But because the denominator has the same denominator in both terms in the denominator, you could combine those into one before you started working the problem. It does help, but again, it's kind of out of the ordinary and out of the, what we taught yesterday, so I don't want to add a wrinkle to it. But if you're confident enough to do that, you could combine the denominator, and then you just have one thing in the denominator to distribute. All right, so what is our least common denominator we could multiply top and bottom by here to get rid of the complex fractions? We need a 25, and we need an x minus 4, right? Because 25 covers 5 and 25, and then the x minus 4 will get rid of these x minus 4s in the denominator. That's correct. So we'll multiply top and bottom by this. So we're multiplying by 1 as long as x is not equal to 4, which it can't be, so we don't need to exclude that at this point. All right, now when I multiply this term by what's over here, what's going to cancel? 5 goes into 25 5 times, and so we're going to be left with 5x times x minus 4. But you could go ahead and multiply that together if you'd like. I'm just showing here that the 5 goes into 25 5 times. You multiply 5 by x, and then 5x will be multiplied by x minus 4. Right. And I want to encourage you to be real detailed about how you do this. All right, these problems get tricky. Now we're going to multiply x plus 4 over 25 by this. And we've got to be really, really careful because this negative sign is in play. It needs to come down. When we multiply those, the 25 will cancel, and I'm going to be left with x plus 4 times x minus 4, which is x squared minus 16. Right? The 25's cancel, and we're left with x plus 4 times x minus 4, which we know is the difference of squares, x squared minus 16 is what you get when you multiply conjugates. Okay? Any questions there? In the denominator, when we multiply this first term by this, the x minus 4's cancel, and we're left with 25 times x plus 4, which you could write as 25 times x plus 4. We could write it as 25x plus 100. Go ahead and multiply it together. Got another negative sign to deal with, so I'm going to go ahead and bring that down. All right. And when we multiply this expression times what's over here, again the x minus 4's will cancel, and I'm just left with 25 times x squared, which is 25x squared. The rest of it's easy, right? The rest of it's pretty straightforward. Any questions about what we've done here? Does everybody see where everything went, and why it went away, and why we multiplied what was left, and how we got that? All right, so simplify the top, and we'll have, let's multiply 5x times x. That's 5x squared minus x squared is going to give us 4x squared. 5x times negative 4 is negative 20x. And then minus negative 16 becomes plus 16. And in the bottom, we're going to have negative 25x squared plus 25x plus 100. Now, both of these expressions can factor. This is kind of where you got to be careful. Both of these expressions can factor. Matter of fact, if we took a 4 out of the top, I think we would have, 4 times x minus 4? No, that's not right. 4 times x minus 2 squared. No, that's not right either. All we could do is take out a 4. It won't factor. It's not interesting, right? We could take a 25 out of the bottom, but will it cancel with 4? It won't. So nothing that we factor out of either one of these can do anything for us, so that's our final answer. Good? Better? All right, let's have a look at number 5. 5 from the homework. X minus 4 over 2x minus 6. I'm going to go ahead and factor 2x minus 6 as 2 times x minus 3. So I have to factor my denominators to see what the common denominator is going to be. So that's 2 over x minus 3. Bottom we have x minus 3 over x minus 4 plus x minus 3 over x minus 4. Now again, you could, it's kind of slick, save you a little time if you combine the two terms in the denominator, because they do have a common denominator. You can combine those together. Just have one thing in the bottom. Saves a little time in the long run, but it's a little out of the ordinary, so let's not do it that way. What will we multiply by here, top and bottom, to get rid of the complex fractions? We need a 2, right, to get rid of this 2 right here. We need a 2. We're going to need an x minus 3, and we're going to need an x minus 4. So what I am multiplying by here is 1 in the form of 2 times x minus 3 times x minus 4 divided by itself. This helping a little bit, Caitlin? Be tough to try to do this without. So we need to multiply this over here. And what cancels when we multiply those two things? The 2 and the x minus 3, so I'm going to be left with x minus 4 times x minus 4, which is x squared minus 8x plus 16. Right? Because the 2 and the x minus 3 will cancel. And we're left with x minus 4 times x minus 4, which is x squared minus 8x plus 16. Okay? Now, the next term to multiply, we're going to multiply this term by this. I'm going to make sure I go ahead and bring down this negative sign, because that's part of the deal. That's very important, right? And what's going to cancel when I multiply those two things? What's going to cancel when I multiply these two things? X minus 3's will cancel, so I'm going to be left with 4, 2, and x minus 4. Right? 4 times 2 is 8, and 8 times x minus 4 is 8x minus 32. Parentheses, they're very important because we're distributing that negative sign in between the two fractions. So the x minus 3's will cancel. Again, x minus 3 cancels. And we're left with 4 times 2, which is 8, and 8 times x minus 4 is 8x minus 32. All right. Now we will go to the bottom. X minus 3 over x minus 4 times this over here. The x minus 4's cancel, right? And I'm left with 2 times x minus 3 times x minus 3. And that might be a little much to do without showing it, right? So that's 2 times x minus 3 times x minus 3. That's going to be 2 times x minus 3 times x minus 3 is x squared minus 6x plus 9. And we get that by canceling the x minus 4's. X minus 3 times x minus 3 is x squared minus 6x plus 9, and then we still got that 2 hanging around. Okay, so we'll clean that up in a minute. Last term to multiply is x minus 3 over x minus 4. When we multiply that again, the x minus 4's cancel, and I'm left with exactly the same thing as the first time, right? X minus 3 times x minus 3. I'm happy about having a plus sign here because I don't have to distribute any negatives. Don't worry about that. So I'm still going to have another 2x squared minus 6x plus 9. Doesn't it make sense I end up with two of the same things? Because I have two of the same things here. Those are the same. So we would expect the things to be the same. All right, simplifying the numerator, we'll have x squared minus 16x plus 48. 48 was right, Brittany. Brittany. The 48 was right. Okay. And in the bottom, 2 of these plus 2 of these is really 4 of those, right? So if you can distribute a 4, you get 4x squared minus 24x plus 36 when you combine these two things in the bottom. X squared minus 16x plus 48 will factor, won't it? Shouldn't we try to factor this? Did anybody factor it?
With the bottom? Oh, wait, no, you're talking about the bottom.
The top will factor as, what, x minus 12 times x minus 4. And the bottom is going to factor as 4 times x minus 3 squared. Nothing's going to cancel, so you can just leave it like this.
Could you do it and leave it like the other one?
Yeah, if you factor it out, that's fine too. All right, any questions? Y'all got a little better? All right, so this is one of the tricky skills on this test, this complex fractions, and the skill's going to carry over into what we start tomorrow and finish on Thursday, solving rational equations.